dark side of the sun. One that blows off streams of hot, highly charged particles into space, the solar wind. Gusts traveling up to 1 million miles an hour can hit Earth within 2 days. An invisible magnetic field generated by the spinning dynamo of Earth's molten core shields us from this scalding wind. But what is the direct impact of the solar wind on Earth? Researchers at the University of California have designed a unique experiment to shed light on this important question. In this laboratory, Hafiz Rahman is trying to discover exactly how the solar wind affects our planet. Rahman has put together a model of our solar system. An accelerator will generate a blast of charged particles. A vacuum chamber will simulate the emptiness of space. And a small model of Earth, called a Torella, is the target. The Torella will be protected by a lab-generated magnetic field. Once the chamber is set and the vacuum ready, the accelerator will fire directly at the Torella. $150,000 amps will generate a wind of particles traveling faster than the speed of sound. Little is known about Earth's magnetic field. It is difficult to measure or define in space. Rahman now hopes to capture the field's reaction to a simulated solar wind.
Charging, 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 fire!
Science has given shape to an otherwise invisible event. The Torella's field is hammered by the wind, distorting and knocking it out of balance. And in the process, it creates an event we know as the aurora. Cranking up the wind speed a notch to simulate solar max, Rahman now hopes to see a change in the aurora. Sure enough, the polar lights brighten. Rahman has discovered that a faster solar wind creates a bigger aurora. This explains what aurora watchers have long known, that during solar max, the dancing lights are brighter and can be seen farther from the poles. Earth's magnetic field swarms with invisible charged particles. When the solar wind strikes the field, particles are kicked like cosmic pinballs down toward the poles. There they crash into our atmosphere to create bursts of auroral light. While scientists are just beginning to understand the power that brings the sky to life, those who live near the poles have long had their own interpretations. Myths of the aurora have been handed down through generations and are still cherished today. It is said that whistling can call up the lights. But children are also warned not to get too close, else they be swept away. Without the polar lights, this land would be dark for much of winter. For hunters traveling without help from the sun or moon, the lights could be beckoned to guide the way.
Oh! Oh! Oh no! Oh!
For shamans, the aurora offers spiritual guidance for a journey to commune with the dead. In this bone-cold land where the sun can vanish for months, nothing is more comforting than the shimmering spectacle of lights. On long winter nights, these Inuit of Hudson Bay recount their own particular tale of the aurora. They see the lights as the souls of their loved ones, playing a spectral game of soccer in the heavens. If you listen hard enough, you can hear the ghostly echoes of their running feet. If in some parts of the world people have a spiritual connection with the heavens, in other places, the sun seems irrelevant. Here in New York City, the cycle of day and night is only a faint pulse masked by rhythms of our own creation. People race around the clock, often too busy to even look up. With a virtual world at our fingertips, it's easy to overlook a higher power.
There are a number of things that we take for granted every day that can be affected by the sun.
Louis Lanzarote is a space physicist at Bell Labs. He tracks advances in telecommunications and is keenly aware of the sun's potential.
It is ironical that as we've become more high-tech and we've become more wired, we have tended to forget nature. And in fact, here in New York City, if we go out at night, we don't see the stars in the Milky Way, and we're not enamored of the sky anymore because all the lights block the sky out. It's the same way with the sun. We don't recognize what the sun can do in terms of disturbances on the Earth. Even though we are so-called high-tech, we still forget that nature is a very important player in our everyday existence.
As we hurtle through a high-tech age, we're becoming more dependent on our sophisticated devices. But the very advances that seem to free us from the cycle of day and night also bind us to the sun in new and unexpected ways. When we approach solar max, the sun is more likely to blast Earth with high-energy particles. Our fast-growing networks, power cables, oil pipelines, and telephone wires all serve as giant lightning rods to catch the dangerous power of solar outbursts. At any moment, the sun could leave us in the dark.
Nature can always throw us a curveball, as we've known since we've monitored the sun rather closely for the last 150, 200 years. And so with a more wired world, we need to be very careful, and we need to be cautious, and we need to look at all the what-ifs to see if nature can get us or not, even if this is not a worse solar maximum than the last 2 or 3 that we've gone through, because several in the last have caused problems.
The solar max of 1989 was when we first began to realize just how devastating a solar blast can be. In March of that year, as the citizens of Quebec slept, no one knew that 93 million miles away, a menacing storm was brewing on the sun.